year. Today we have the entire current science and technology crew here. We have Julia Sable.
Hello.
Sophie Schrand.
Hi.
Sean Fankhauser.
Hello.
Kareen Tate.
Hi.
And I'm Susan Heilman. We've survived another year, and that means that the current science and technology team have come up with our top 10 science stories for the previous year.
And speaking of surviving, we have also all survived the projected end of the world. For a while, there was a lot of concern about the end of the Mayan calendar on December 21st, 2012, but it turns out it was not, in fact, the end of the world. The Mayan calendar is actually circular, and so it really just represented the start of another circular cycle. And with that, here's Juliet to talk about our number 10.
Number 10 is the 3D printing revolution. 3D printing has been around for a long time. It's not that it's a brand new technology, but it is becoming widespread and finding a whole bunch of new applications.
So if this is old technology, what's really new from this past year?
One thing is that in the past, 3D printing was better for just making prototypes that aren't very durable, but now there's more use of 3D printing for actual manufacturing of metal parts for machines. Then there's the continuing revolution in personal use, like desktop 3D printing. And companies like MakerBot are now selling 3D printers for a little over $2,000. Still kind of a lot, but the cost has come way down, and it's becoming a real possibility to 3D print stuff in your home. That's usually printed out of plastic. But then there's also some other materials being used, especially in medicine. At the beginning of 2012, a Belgian university and a manufacturing company published a successful transplant of a titanium 3D printed jawbone in a patient. And there are several researchers working with 3D printing living cells. So they're working toward 3D printing human organs or human tissue. At this point, we're at least 10 years away from printing a real working human organ, but there have been 3D printed blood vessels, heart valves, cartilage, and a lot of experimental tissues that seem to be useful for studying disease or for testing new pharmaceuticals. There's even ideas that we could 3D print replicas of tumors so that surgeons could practice on removing tumors.
Very cool.
So we may be a long way from 3D printed organs, but there have been some amazing strides in the past year with 3D printing in medicine and other realms. So now I will ask Susan, what's number 9?
Number 9 is also not necessarily a new area in science, but social media has come a really long way in the past year. In October of 2012, Facebook hit 1 billion users, billion with a B. So more and more people every day are joining various social media networks like Facebook, Twitter, Tumblr. There's literally hundreds of them that people can choose to be a part of. And it's not just a social revolution, but it also has changed the way science is done in some ways. Various types of scientists, like sociologists and psychologists, are interested in studying how and why people use social media, how and why social media can be used for other things. It talks about using things like Facebook to encourage people to vote during elections.
So, Susan, these scientists are not only looking at how Facebook is used, but they themselves are using Facebook to do some of these studies?
Yeah, exactly. They're able to get thousands or even millions of people as parts of their studies because of the wide range of the social media sites. And they're also using it to gather information. The Department of Homeland Security is using it to track disease outbreaks. And doctors often use it to communicate information about diseases that they're studying and to not only connect with other doctors who might have information for them, but they'll also post information themselves. And it's something like 20 to 30% of doctors are using social media for these purposes.
Wow.
Next, we have our very own geologist, Julia Sable, to talk about our number 8.
In fall 2012, some Italian government officials and seismologists were convicted of manslaughter for failing to communicate the risk of an earthquake satisfactorily.
I remember hearing a little bit about that. Can you give us some of the backstory?
There was a damaging earthquake in L'Aquila, Italy in 2009. The months before that bigger earthquake, there were a lot of little tremors that had the public really nervous. They wondered if they should evacuate. Then the seismologists and government officials met and discussed the fact that there is no scientific evidence that a bunch of little earthquakes means a big one is more likely.
So they basically said that a large earthquake can't necessarily be predicted.
That's true. We can't predict earthquakes, but the way that it got communicated to the public made it sound like there is no risk of a big earthquake. And so people who might have evacuated chose to stay. Then the damaging earthquake happened in April, and some people died that it is argued maybe wouldn't have died if they had evacuated. So that's the problem, is these scientists and government officials are accused of putting people at risk because they communicated this wrong. But it brings up this question of there's a lot of not just earthquakes, but there's a lot of natural hazards that we need to look to experts to help us understand the risk. Volcanic eruptions, tsunamis, hurricanes. There's a concern that now scientists will hesitate more to tell people what the risk is because they don't want to go to court for it.
So it sounds like the communication of risk and probability of a certain event happening needs to be maybe better communicated between the scientists and non-scientists in the world to help maybe avoid this type of situation in the future. So now we'll move on to a smaller scale, so to speak, for our number 7 story with Kareen.
I am pretty excited about this new technology that's been developed. We've heard quite a bit about nanomedicine in the last couple of years, but these therapies take time to make it through the FDA approval process before we can use them with patients. And our number 7 story has to do with a new nanoparticle cancer therapy that is one step closer to being used with patients. They've had positive results in human clinical trials using a tiny engineered nanoparticle that targets cancer cells and delivers chemotherapy right to the cancer cells, limiting the side effects on the rest of the body.
How is this particular nanomedicine different from those in the past?
A lot of nanoparticles thus far have been used as imaging agents or even drug delivery particles. But this is the first time that a nanoparticle has been designed to be targeted. It has all these targeting molecules on the surface of the nanoparticle that help it find and recognize receptors on the cancer cell. It also has a stealth coating around it that helps it evade the body's immune system and stay in circulation longer, giving it more of a chance to find the cancer cells. And the release of the chemotherapy it contains is controlled. It's able to release more of the drug once it's found its target.
So this is being used in humans right now? It's in a clinical trial stage? When can it go mainstream?
Earlier in 2012, Bind Biosciences, the company that created this nanoparticle, released really positive results from their first phase of clinical trials, showing that it was safe and effective in shrinking the tumors with fewer side effects and even lower doses than we typically use for those treatments. So as far as when we're going to see it, that's a hard question to answer, but they are getting ready for the next phase of clinical trials, phase 2. So hopefully this is something that we're going to see used in the next few years.
And with that, we turn to our in-house meteorologist, Sean Fankhauser, for our number 6 science story.
The bottom line of this story is that climate change continues again into the year 2012. Globally, we're talking about probably a year that ends in the top 15 warmest on record, with records going all the way back to 1880. In the United States, we're probably talking about number 1. Those figures will finally come out later on in early 2013.
Right, so this being one of the warmest years on record, does that have anything to do with the melting sea ice we've heard about?
Arctic sea ice certainly did reach a record low earlier this fall. Back in mid-September, it reached its lowest extent on record, with records going back to 1979. And it happened in the Arctic with temperatures not being as warm as they have been in the past. So some sort of climate regime has kind of set in, and Arctic sea ice is having a really difficult time lasting and maintaining its extent in the Arctic at this point. The extent of Arctic sea ice depends more on just the atmospheric temperatures globally or even in one specific region. There's a lot that can affect that sea ice, and climate scientists are still trying to figure out exactly what all those pieces are. There was a story earlier this year about polar storms having a big effect on this ice extent.
Were there any other climate-related records broken in 2012?
Indirectly, yes. Carbon dioxide emissions are projected to be at their highest level on record for the year 2012, reaching 35.6 billion metric tons. And carbon dioxide has been implicated as a major contributor to our warming climate.
So we've made it halfway through our top 10 list, and here to continue on with number 5 is Corrine.
So our next story is about our ability to decode DNA faster, easier, and more cheaply than we've ever been able to. The human genome is more than 3 billion base pairs. That's a huge amount of information, and decoding that much DNA takes a lot of time. A new method for sequencing DNA is really gaining popularity, and it's called nanopore sequencing. Instead of taking DNA and chopping it into tiny pieces, amplifying it, labeling it, this very complex process that we used to use, we can simply take a single strand of DNA and pull it through a membrane that has a tiny hole just large enough for that DNA strand to fit through. And this membrane conducts electricity, and we can measure the current that's flowing through the membrane. Now, as we pull the DNA strand through this tiny pore, it affects that electrical current, causing these slight variations. By measuring those variations, we can tell exactly which base pair is being pulled through that membrane at any given time, resulting in a much simpler process than we've ever had before.
So, what does this mean?
So our ability to do this better and faster and cheaper has a lot of applications. For example, there's been a big project, a huge data gathering project called ENCODE, which stands for the Encyclopedia of DNA Elements. And in this project, hundreds of researchers around the world are working to figure out the biological function of all of this information. And previously, we thought that more than 90% of human DNA was junk. It was called junk DNA because they didn't think it had much purpose. And through this project, earlier in 2012, they released studies that showed as much as 80% of that actually has important biological function as gene regulators and gene promoters. So it's really changed our understanding of what our DNA does.
We now go back to our meteorologist, Sean, for the number 4 story.
So this story is one that impacted tens of millions of people up and down the east coast of the United States and in the Caribbean as well. We're talking about Superstorm Sandy that set many records, especially as it approached the east coast of the United States. In New York City, in the harbor, they recorded a 32.5-foot wave. That is huge, and those waves eventually make it on shore and caused a lot of damage, as we've all witnessed from some of the pictures we've seen there.
But this was only a Category 1 hurricane, and in some places it wasn't even a hurricane. Why was so much damage caused?
So technically, as it made landfall in New Jersey, Superstorm Sandy was a post-tropical system. We won't get into the semantics of all of the terms that are used by meteorologists, but technically it wasn't purely a hurricane, nor was it purely like a nor'easter. It was a combination of the two, and without those characteristics, it would not have done as much damage as it did. One of the biggest reasons it caused so much damage was because of its size. At its largest, it was 1,000 miles in diameter. That is huge. A storm that size can push a lot of water on shore and cause major damage, especially along a highly populated coastline like that of the northeastern United States.
Superstorm Sandy was huge in the headlines, and there was another one also in fall 2012 that made big news, and that is our number 3. Sophie?
In fall of 2012, the United States experienced something we refer to as the meningitis crisis, where an outbreak of fungal meningitis infected hundreds of people, causing dozens of deaths. Now, this is notable for a number of reasons. Fungal meningitis is incredibly rare.
Sophie, what is meningitis?
Well, meningitis is an inflammation of the meninges, being the protective covering of the brain and spinal cord. It can be caused by a number of things, but to be caused by a fungus is very, very rare. Our human bodies are pretty good at keeping fungi out of our bodies.
So where did people get this fungus from?
Within 1 week of the first case of fungal meningitis being noted in Tennessee, the CDC was able to pinpoint the source of the fungal meningitis outbreak to a contaminated epidural steroid injection, and were all traced back to having come from one particular place, the NECC, the New England Compounding Center in Framingham, Massachusetts. So now the NECC is under investigation for a number of different things. They have recalled all the medications that they had distributed and have stopped production of any new medications.
How did these contaminated steroids get out to the public?
There's no real simple answer to that, because this meningitis crisis exposed failures at a number of different levels. On a state level, at the level of the New England Compounding Center, a number of mistakes were made that led to these medications becoming contaminated in the first place, and then led to those contaminated medications being given to patients. Now that this has been exposed, a lot of people are talking about regulation and how we are going to improve regulation so that we can make sure that this kind of outbreak never happens again.
Well, thanks for explaining that, Sophie. We're getting close to our top stories, and I'm curious to hear a little bit about number 2. Susan?
I get it, you're curious, because number 2 is about Curiosity, the car-sized Mars rover that landed on Mars in August of 2012. There's so many interesting things about the Mars Science Laboratory mission. The landing in and of itself was pretty cool in that they didn't use the past airbag bouncy balloon approach to land it on Mars, but instead they used a sky crane where they had the rover inside of kind of another little spaceship that fired rockets and slowed it down to 2 miles per hour and then gently lowered it to the surface of Mars.
So what has the Curiosity rover been up to since landing?
Well, after a few days of checking out all of its many different cameras and pieces of equipment that it has, the main goal for the Curiosity mission is to determine the habitability of the planet Mars. We have solid proof that there is right now ice water on Mars or just below the surface. We now have some pretty good evidence that at one point there was liquid water on the surface of Mars. Liquid water being very important for life as we know it on Earth. The main thing that Curiosity is looking at, besides evidence for liquid water, is possible building blocks of life known as proteins, or actually what proteins are comprised of, which are amino acids. And so there's a number of different pieces of scientific equipment on Curiosity that allows it to drill and shovel and scrape and analyze to look for amino acids.
How long will Curiosity be at work up there?
It was initially set for a 2-year mission, but in just the first few months, Curiosity has done so amazingly well that in December of 2012, they extended the mission indefinitely, or until its plutonium fuel source runs out, which is calculated to be in about 55 years. So barring any major engineering crises, we can expect to get some amazing news from Curiosity for quite some time.
And now,
drum roll, please.
And now, the current science and technology team presents our number 1 science story of 2012.
On July 4th, 2012, scientists announced that they have convincing evidence that they have found the Higgs Boson.
Sophie, what's the Higgs Boson?
That's a fair question, Corrine. The Higgs boson has been theorized since the 1960s to be the particle that gives all other particles mass. Now, what does that mean? Well, we know that things have mass, but where did that mass come from? in 1964, Peter Higgs theorized that there is something called a Higgs field, and that all particles pass through the Higgs field and interact with this thing called the Higgs boson, and that gives them mass. Now, this has been theoretical because up until now, there was no way to find evidence of a Higgs boson.
Sophie, how did they find this convincing evidence of the Higgs boson's existence?
Enter the Large Hadron Collider. It's the world's largest atom smasher. It's underground in Europe, and they were able to reach such high energies with this collider that they were able to see this convincing evidence of a Higgs boson. The reason why physicists are so excited by this discovery is that the existence of a Higgs boson would reinforce the current theory about how the universe works and would help to explain all these forces that govern our universe.
That was a massive discovery.
Good one.
So that's the Current Science and Technology team's top 10 science stories for 2012. We hope all of you have a healthy, happy, and safe new year. That's it for this week's show, but be sure to come back next time for more of the latest in science and technology. This podcast is a production of Current Science and Technology at the Museum of Science in Boston, part of the Boston community for over 175 years. For more information, visit our website at www.mos.org/CST or email us at podcast@mos.org. Thanks for listening.